Good morning, and today I'll be explaining to you how to solve question 23 from Energizing Physics lesson 3.9. In question 23, you're given that a person is pushing up a box against a wall, but he pushes at an angle so that the force of the push can be split up into an x component and a y component. And so the total force of the push is equal to 250 newtons, but it can be split up into an x component of 150 newtons and a y component of 200 newtons. The mass of the box is 10 kilograms. You're also given that the displacement is 0.5 meters, and that the coefficient of friction between the box and the wall is 0.4, and that the box starts at rest. So what you're trying to find here is the velocity after the displacement. So the important concepts to remember are that F friction, the force friction is equal to the coefficient of friction times the normal force. For the force of gravity is equal to mass times g. E1 plus work equals E2. Work is equal to force times displacement. Kinetic energy is equal to 1/2 mv squared, and that in this instance, net force will equal the F push y minus F friction minus F gravity. And first, solve for the force diagram. You have to solve for all the forces acting on the box. And so F gravity is equal to mass times g, which is equal to 100 newtons. In this case, since the box doesn't move left or right, it stays pushed against the wall the whole time, the normal force will be equal to F push x, which is equal to 150 newtons. And so, using that, we can solve for the force of friction, which is equal to 60 newtons. And so, with all the information, we can draw the force diagram of the box. The force of friction and the force of gravity both go downwards. And the normal force pushes outwards away from the wall, perpendicular to it. But the force of push, the pushing force goes diagonally upwards like that. And so that's the force diagram. And so, that's the force diagram. Now to solve for V2, we have to solve for F net, which is equal to 200 minus 100 minus 60, or 40 newtons. And so, since the box is at rest at the first point, E1 is equal to 0. Plugging in the variables we have for work, we can solve for E2. E2 ends up being 20 joules. And so 20 is equal to the kinetic energy at that point, or 1/2 mv squared. So solving for V, we get V equals 2 meters per second.